All right. As you've been working through some of the content that I've given you looking at ice core drilling and the information that we can get from ice core drilling and why we care about drilling ice cores, words like combustion and hydrocarbons have come up a few times. Now, when we are looking at the atmospheric samples that come out of the ice cores, it's telling us how the levels of carbon dioxide have been changing in our atmosphere over the last hundreds of thousands of years. And it's really interesting to see that data. Now, we're going to do a closer look at what is causing those changes in carbon dioxide to happen, which you have probably already discovered. You already know it's because of combustion of hydrocarbons. Now, before we continue to dig in deeper, I want to just talk about what does combustion of hydrocarbons mean. Now, combustion, you're going to want to copy this down, by the way. Combustion is a scientific word for burning. Basically, it's when a substance reacts with oxygen in the air and it produces heat or light. Okay. And so combustion, fancy word for burning. Hydrocarbons, these are compounds that contain only hydrogen and carbon. Now, you would think, well, there can't be a lot of hydrocarbons. In fact, there's hundreds of thousands of different kinds of hydrocarbons, and we're going to learn more about those different types of hydrocarbons in the lessons to come. But for now, we can just recognize that these hydrocarbons exist. You can have solid hydrocarbons, liquid hydrocarbons, or hydrocarbons that are a gas. And hydrocarbons actually include most common fuels that we already use. So something like propane in your barbecue, propane is a hydrocarbon. So if we think about what these words mean, we look up, combustion of hydrocarbon really just means that we're burning carbon and hydrogen. Now, you've already looked at some videos that is showing you what happens when we burn carbon and hydrogens and the products that result. So what the products of combustion are. Now, we're going to put this information in our notes, but I want to just remind you that we have two types of combustion. Okay, so these are our two types. I have them right here. You can hit pause and copy this down. And listen, and then listen, or listen and then hit pause and copy it down. So complete combustion, this is the type of combustion that is putting all that carbon dioxide in our atmosphere. So when we take a hydrocarbon and we react it with oxygen gas from our air, and it makes carbon dioxide and water and that energy, which is the reason why we combust hydrocarbons. Okay, really we're after the energy, the heat or the light. So I've just written out a nice example right here. This is the most simple hydrocarbon that exists. It's called methane. It's natural gas. So some of you might cook with it at home or heat your houses with it. It's also the fuel that we use for our Bunsen burners in our science lab. Okay, so our methane reacting with oxygen, making carbon dioxide and water. And if you look, you're going to quickly see this equation is not balanced, and that's okay because that's not what we're working on right now. The other type of combustion is incomplete combustion. Now, incomplete combustion does not put carbon dioxide in our atmosphere. It still gives us the energy, but there's one big downfall. Incomplete combustion is when you have a hydrocarbon and oxygen gas, but there's not enough oxygen gas. And so instead of making carbon dioxide, it ends up making carbon monoxide, okay, which is poisonous. We still get water, and it also makes a solid carbon, or what you would call soot. So although incomplete combustion doesn't make our greenhouse gas, carbon dioxide, it's actually very dangerous for humans because if you breathe in carbon monoxide, it will suffocate. You will suffocate, and if you don't get enough medical attention really quickly, it could essentially suffocate you to death. And it also makes this soot, this dirty, solid carbon, which is a huge pollutant. Now, I told you earlier in our lesson that there is like hundreds of thousands of different types of hydrocarbons. So what we're going to do is we're going to dig a little bit deeper into our different kinds of hydrocarbons. And in order to do that, I think we will look at how chemists name hydrocarbons. Okay. All right, and to do that, we are going to look at some examples. So I'm going to leave a couple lines for a reason, so I think you probably should too. So in my example, here's my example. I'm going to draw you a structure. I'm going to write up here. Structure. And here's my example. I'm going to do the easiest, most simplest hydrocarbon that we have, CH4. Here we go. CH4. Okay. Now, CH4, this is what it looks like if we drew it out on paper. Now, that's a super big pain in the butt. So sometimes we will draw a condensed structure, which for methane looks like this, CH4. Okay. And we'll also write out the molecular formula, which looks exactly like the condensed structure for this one. And we'll name this most simple hydrocarbon. So the name for this simple hydrocarbon, I know you've heard it before. The common name is natural gas, but the scientific name is methane. So let's look at another example. So our next example, this time, my structure is going to look like this. I'm going to have two carbons bonded together, and I am going to bond in some hydrogens. Okay. So this one's pretty easy. We're going to do our formula first. Okay. So our formula is we have two carbons. You can see that. And if we count up our hydrogens, we have 6. So that's our formula. Now our condensed structure, I'm going to show you this way. So if we wanted to communicate this carbon with 3 hydrogens, we're going to write CH3, and then to communicate this carbon with 3 hydrogens, we're going to write CH3 right beside it. Okay. So if we have this simple hydrocarbon that has 2 carbons and 6 hydrogens, this is called ethane. Okay. We're going to do 2 more. I'm going to do our next one. You probably guessed it. It has 3. So we're going to draw a chain of 3 carbons bonded together. And then hydrogens. Now you're probably wondering, why isn't she making hydrogen bond? Why can't we put hydrogen in a chain and make 2 bonds? It goes back to the idea that hydrogen only has that first orbit of electrons. It can only hold 2 electrons. So it can only make 2, or it can only make 1 bond. So this hydrocarbon, let's take a look at its condensed structure. I'm sure you're going to figure this one out pretty quickly. So CH3, and then right here. So now we have a carbon in the middle. It only has 2 hydrogens, so we have to make sure we only write that out. And maybe orange. Did it even go? Yep, okay. CH3, so that's our condensed structure for this hydrocarbon. If we count up all our molecules and types, we get our molecular formula. So this has 3 carbons. And if we look, there is 1 here. I'm going to even just do this. Oops, go away. 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. So we can write that here. And this hydrocarbon is called propane. Something you know what propane is. You probably have heard of it. And then we'll draw our last one. And it is going to be a chain of 4 carbons. Every single carbon makes 4 bonds. That is kind of a secret of hydrocarbons. So we complete this up. I'm not going to color code our structure or condensed structure because you guys probably got this figured out already. It's going to look like this. I'm running out of space. Our formula is C4H10. You can count up those hydrogens. And if we named this, we're going to call it butane. Okay, so you can imagine that we can just keep adding and adding and adding and adding and have an endless chain of carbons, okay, an infinite number. That we're going to also look at how you can add branches to your big chain of carbons. And so you can probably start to see that, yeah, you can have like hundreds of thousands of different types of hydrocarbons. Now, I want you to look at the names of these compounds because they all have something in common. Can you see it? If you look, you can see that we have a methane, we have ethane, we have propane, and we have butane. Okay. This is called a suffix. Okay, it's the ending of the name. And what this tells us is that all of them have single bonds. They all have the ending "ane" for a reason. So our ending of their name is telling us the type of bonds that exist in the compound. And then where the names differ has to do with the beginning of the names: meth, eth, prop, but. What this part of the name tells you is the number of carbons. So when we're naming our hydrocarbons using the scientific names, their name has 2 parts. I'm going to write that down. So the name has 2 parts. It has the suffix, so the ending, which, our ending of the name tells you if it has single, double, or triple bonds. So when it has ane means single bonds. We're going to learn later how we name something when we add a double bond or a triple bond. Maybe I'll just write in here. So ane is single. Actually, I'll write them all in. If the ending is "ene," it's a double. There's double bonds. And if it has the ending "ine," it means that there are triple bonds. It's important to remember that these double, triple bonds only matter between carbons. Okay, so the ending of the name tells you if it has single, double, or triple bonds. And then the prefix of the name. So the prefix, which is the beginning, tells us the number of carbon. So you already know the prefixes for the first 4 carbons. There they are right there because we've already drawn out some of those hydrocarbons. If we have 5, it gets the prefix pent. 6 is hex. 7 is hept. 8 is oct, like octane, which is in your gasoline for your car. 9 is non. And 10, if you got 10 carbons, it's dec. So just remember that if we're naming our most simplest of hydrocarbons, we go number of carbons plus either ane for single bonds, ene if there's double bonds, or ine if there's triple bonds. So I could ask you to do something like, I don't want that to be purple. I could ask you to do something like draw heptane. Oh, that's pretty messy. And you would go over here up to your little chart of your names. And you would go, okay, hept means, wait a minute. I want to keep my colors simple the same here. You would go hept is the prefix. It means 7 carbons, and ane means they are all single bonds. And you would be able to quite easily go 1, 2, 3, 4, 5, 6, 7. And then you would add all your hydrogens. Just like this. It's kind of boring, but got to make sure they're there. Every carbon should have 4 bonds on it. That's a big, huge rule. And then if I asked you just to show complete combustion of heptane, you would be able to do that too, because you know that complete combustion is the hydrocarbon, and you know heptane has 7 carbons, and then you can count your hydrogens. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You know it reacts with oxygen gas. You know it's going to make carbon dioxide and water and energy. And then you know how to balance. So you can quickly balance. I'll balance it in green. It looks like I've got to balance my carbons. So 7 carbons here. And it looks like I have to put an 8 in front of my hydrogen. So I have 16 on each side. I want you to notice that I left hydrogen and oxygen till the end. I did carbon first and then my hydrogens. And then I'm going to look at my oxygens. I have 14 plus 8 oxygens is 22. So that means I need to multiply this one by 11. Okay, and that is combining what we know about combustion and hydrocarbons to show combustion of our hydrocarbons. And we're going to use this a little bit more, and we're going to continue to look at different kinds of hydrocarbons as we move through our topic.